Okay, good evening, students. Can you hear me? Okay, right. Now, today we just discussed about the next two gates. Now, last time we discussed about AND gate, OR gate, and NOT gate. Those are three basic gates. Then we have the NAND and the NOR gates. So, NAND gate and the NOR gates we call as universal gates. That also we discussed in the previous class. Now, here we just discussed about the next two gates in the syllabus, that is exclusive OR. So in the exclusive OR and the exclusive NO are the next two gates that you should know. So exclusive OR we just write as XOR. Now remember this exclusive OR notation is this one. We just write exclusive OR, it's an operation, but we put a circle to make it exclusive. And the Boolean expression equivalent to the exclusive OR is that A B bar plus A bar B. So that is the Boolean expression that you should know for the exclusive OR. And the logic gate, remember, it looks like the OR gate, but there will be parallel lines like this. Then it is what we call the exclusive OR logic gate. So to get the truth table, since you know the expression here, the Boolean expression here, we can get the truth table. And again, remember this exclusive OR, since it is equivalent to this expression, the exclusive OR logic gate, we can draw like this also because it is equal to the A bar, A B bar plus A bar B addition. So that is a Boolean expression here. Now to get the truth table output, yeah, I will give you the tut for this one. Now, some of you I have already given this one, but if you have not received, just let me know in the class. I will give you the tut. So then the truth table, how do you get the truth table for this? You can easily get the truth table since you know the Boolean expression here. The Boolean expression is A bar B. So if you substitute the value now, initially both A is 0, B is 0. So if you substitute 0 here, this will A will be 0, B will be 0. Then the answer will be, when you multiply, answer will be 0. But when you take the next value, A is 0, B is 1. Remember, when the A is 0, this is not 0. Not 0 means 1. Then the B is 1. So 1 into 1 is 1. Therefore, answer will be 1. Then the A is 1, B is 0. When the A is 1, remember this will be 1. B is 0 means not 0 is 1. Then 1 into 1 is 1. So the answer will be 1. Then finally, both A and B are 1. So in that case, when the A is 1, this will be 0. When the B is 1, this will be 0. Therefore, 0 into something will be 0. Answer will be 0. Therefore, you have to just remember the truth table for the exclusive OR will be 0, 1, 1, 0. That is when the both inputs are equal, answer will be 0. When the both inputs are different, the answer will be 1. So that is what you should remember about the exclusive OR gate. And then next one is exclusive NOR. So exclusive NOR means not exclusive OR. So then the logic gate, only difference here is that actually you can see there's a circle here. This circle indicates the NOT operation. That means same exclusive OR, then you get the bar. So we can show that by using the De Morgan's law, we can show that this exclusive NOR equals to AB multiplication plus A bar B bar multiplication. Using that, we can prove the exclusive NOR is equal to that Boolean expression. Now, exclusive O is equal to A B bar plus A bar B, but For the exclusive no, it is equal to AB plus A bar into B bar. Then the truth table will be the inversion of the truth table of the exclusive O. That means 0 will be 1, 1 will be 0. So that way you need to remember the truth table for the exclusive no. Are there any questions? Okay, then that is what you have to remember about the exclusive O and the exclusive NOR gate. Now let's take some examples. Now in this one, we want to find out the expression for the output. So you can write the expression now. This one is actually just a multiplication of A and B. And this one is equal to the A exclusive B. A exclusive B. Exclusive operation we represent by the circle. Like this. So that should be the answer for this question. And here the answer is actually this one is A into A bar. This one is B into B bar. This one is actually AB bar. So you have to have the bar. So this one is A into A bar. This one is B into B bar. This one into AB bar. And then this is equal to A into A bar multiplied by B into B bar and then bar again. So it should be equal to A into A bar and B into B bar, and then this is another NOT gate, therefore bar here. And these two should be multiplied together. So the final answer should be A into A, B into B, and AB bar. So it should be A into A bar, B into B bar, another bar, and this is AB bar, and both should multiply together and bar. That should be the final answer for this logic gate. Then if you take the other question here, so this one should be equal to A exclusive, B exclusive, and C. That's exclusive operation with 3 inputs. It should be A exclusive, yet of the circle, and B exclusive and C, like this. So this one output should be equal to, one is actually A into B plus addition A into C plus B into C. So actually these two are gates for, this is the gate for the half adder and this is a gate for the full adder. We'll discuss that in later actually. That is for addition of the two numbers for half adder, additional 3 numbers in the full adder. We will discuss those two later actually, half adder, full adder. So then in this one, again, you can see this is actually S1. S1 should be the output here. That will be the exclusive B. That should be exclusive B. And then that should multiply with C actually. Therefore, here the output should be equal to A exclusive B and exclusive. Therefore, A exclusive B and B exclusive C. Then this one is actually, you can see it is AB, multiplication AB. This one is S1, A exclusive B with addition actually. Here you get C. So therefore, this should be equal to A exclusive B that should multiply with C. A exclusive B that should multiply the C. And then those two should be added. This one and this one should be added here as output. So that's a Boolean expression you will get for the output. Then other cases are not difficult, therefore I just skip that. You can just try out later. Then I just want to come to this some of the questions that are there. So if you go to the exercise 5, now this question is asking, you have a logic gate. Here it says that B is always 1. When the B is 1, what should be the output of this gate? Now we know that this is actually AND gate. So AND gate, here we have the two inputs A and B, and then the output Q. So we want to find the relationships between these inputs and the output. But in that case, actually, we know that here they have mentioned always B is 1. A is 0, B can be 1. A is 1, B can be 1. Those are the only possible inputs. Now, this is actually AND operation. AND operation means multiplication. So, when you multiply 0 into 1, answer will be 0. And 1 into 1, 1. So, then you can see the answer will be 0 and 1. So, that means answer is 0, 1. That is this answer. That means it is equal to the A. Same as A. Therefore, Q is equal to A. That is how you should decide the output. Then if you check the next question, now in this one actually you are asking, given below is the truth table for the logic gate with the input A, B and Q. So you are asking what is this actually. Now here, if you take this gate and if you invert the values here actually, the output value here, if you get the inversion of this, now see 1 will be 0, 1 will be 0, 1 will be 0, 0 will be 1. That's the inversion actually. This inversion we know that you are getting by doing the AND operation. AND operation. Therefore, this output is AND. Then you can say the Q should be inversion of the AND. That means not AND, not AND means NAND. Therefore, this logic gate is for the NAND gate. That is for the NAND gate. Now, if you have any doubts or questions, you can ask. Then this question, again, similar to the previous one, if you draw the truth table, that will be easier. Now, in here, actually, we have AB inputs and AB multiplication and AB bar. So, if you look at the relationship between the inputs and outputs, so here we can draw the truth table. Then you can see the inputs are, here it says that A can be 1 only. So A can be 1, B can be 0. A can be 1, B can be 1. Those are the possible values. When you multiply, what happened? 1 into 0, 0. 1 into 1, 1. So that is the multiplied results. But this is actually what we call, this is a NAND gate. Therefore, this is bar, AB bar. Then when you make the inversion, the answer will be 1 and 0. So this is actually inversion. This answer 1 and 0, this will be inversion of the B bar. So therefore, the answer should be B bar. That's how you should decide the answer for this kind of question. Then if you check the next one, so you're asking to find out the Boolean expressions for the output. So I think it's a bit easier. Now this one is basically x into y multiplication. And this one should be x plus y bar. It should be x plus y bar. And these two should be added. So then it should be xy, x plus y bar. Yeah, it is actually first one. First one. That should be the answer. Then now when you are given this kind of question, actually there are two ways to do this. One is you can get the Boolean expression and you can apply the rules and simplify and find out which two are equivalent. Now, since we have not yet studied the rules, now we are going to study in the next lesson. Actually, we are going to discuss about the rules in Boolean algebra. So, what is the easier way is actually create the truth table. You can create the truth table for the given circuit, and then you can create the truth table for the each circuit. Now, here the inputs are A and B, only two inputs. Then you can get the output. So you can easily create the truth table and then find out which two tables are equivalent or equal. Now here we know that inputs, the possible inputs are 0 and 0, 0 and 1, 1 and 0, 1 and 1. So those are the possible inputs actually here. Then you can input the 0 and 0 and see what is output. Now when you input the 0 and 0, this will be 0. This will be 0, but when this is 1, this is a multiplication. 1 into 0 is 0. And if you put the 0 and 1, then this will be 1. 1 into 1 is 1. If you put 1 and 0, the answer will be 0. If you put 1 and 1, answer will be 0. So this should be the output. Then what you can do is you can draw the truth table for the first answer. Now the first answer here is this one. So for that you can draw the truth table and then you can check whether these truth tables are equal. The truth tables are equal, that means Boolean expressions are also equal. So then here again you can take the inputs 0 and 0, 0 and 1, 0, 1 and 1. So those are the all possible inputs here. Then if you substitute each input, now here initially 0 and 0, this will be 0, this will be 0, this will be 1. 1 plus something is 1, not 1 is 0, answer will be 0. The next one is 0 and 1, so this is 1 and this will be 0, 0 plus 0 is 0, not 0 is 1. When you put 1 and 0, we know answer will be 0. 1 and 1 also answer will be 0. So therefore, this logic gate and this logic gate out, so this truth table and this truth table outputs are equal for the given inputs. Therefore, this logic gate is equivalent to the first one here. That's the way you can decide this answer. But once you learn the rules, we can apply the rule also and then make the simplification. This question also, it's a kind of good question actually. Now again, you can take the A and B inputs and then find out what are the outputs. That's the issue you can do the answering. So A and B and the Y output. You can just create the truth table and find the relationships. Based on that, you can decide the answer. So then again, here the possible inputs are, remember, both inputs can be 0 and 0, 0 and 1, 1 and 0, 1 and 1. So those are possible inputs. Now here, what do they say? When the x is x is the input actually. X is the input we are given. When the x is 0, you can see this will be 0. We know that in AND gate is a multiplication. AND gate is a multiplication. Then you know that it doesn't matter what's the value for the B. When this other input is 0, 0 into something is answer will be 0. Therefore, this y does not depend on the B. Whatever the value of the B, when you multiply by the 0, answer will be 0. But the answer will depend on the A, because if the when you input 0, this will be 1 actually. When this is 1, if the A is 0, answer will be 0. If the A is 1, answer will be 1. Therefore, in that case, answer will depend on the A. Therefore, this is wrong. The answer will depend on the A. The first part is okay. Answer will depend on the A. Then we can take the other one. We can take the other input. So the other input is here actually x is 1. When the x is 1, you can see this is 1. And this is 0. When this one is 0, it doesn't matter what's the value here. The answer will be 0. This answer will be 0. Therefore, y does not depend on the A. But when this is 1, if the B is 0, answer will be 1 into 0, 0. 0 plus 0 is 0. If the B is 1, 1 into 1, 1, answer will be 1. So therefore, answer will depend on the B. So therefore, answer is A and B. That should be the answer. Then this is, I think, bit easier. First one is A plus B, and that is multiplied with the C, and that is multiplied with the D. A plus B multiplied by C and multiplied by D. And then finally added with D bar. That is actually answer is 2, second one. Answer is 2. Now, in this question also, actually, what we need to do now, we are asking which are equal. So what you should do, you need to get the truth table. So you need to get the truth table for the first one and get the output. And you have to draw the truth table for this one and get the output. Then draw the truth table for this one and get the outputs. So in that case, actually, you can do the truth table here, truth table for this one, and truth table for this. Like you can get truth table inputs. So then what you can do is you don't integrate the Boolean expression, you can input each value. Now initially 0, 0. Then you can see what happened when you put 0 and 0. Then you can see this will be 0 and this will be 0, this will be 0, answer will be 0. And here also you can put 0 and 0, this will be 0, this will be 0. The answer will be 0 actually. When you put 0 and 0, this is 0, this is 0, answer will be 0. Yeah, all are equal. Then you can put the 0 and 1. This is 1 actually. Then 0 into 1 is answer will be 0. Then this is 1, 1 into something, answer will be 0, answer will be 0 here. Then you put the 0 and 1, 1 into something is 0, and 0 plus 0 is 0. Then if you put 0 and 1, this will be 0, this will be 1, and this will be 1, again answer will be 0. Put 1 and 0, this will be 1 and this will be 0, then the answer will be 0 here. And this also 0. And this is 1. So when it is 1, answer will be 1. When it is 1 and 0, this will be 0, and this is 1 means answer will be 1. When it is 1 and 0, this is 0, answer will be 0. Then this is not equal. Then you can put 1 and 1. When this is 1, actually answer will be 1. When it is 1, answer will be 1. So therefore, first two are equal. First two are equal, 1 and 2 are the equal one. We want to find the answer here, then you can put each input 0 and 0. When it is 0, this will be 1. 0 plus 1 is answer will be 0. Then this is wrong. This is okay. This is okay. This is okay. When it is 0 and 1, this will be 1. 1 plus 1 is 1. Answer will be 0. This is okay. This is wrong. This is wrong. Therefore, the answer is this one. You can check the other parts also. Then this one, again, you can use a truth table. You can use a table and check whether which two are equal. So otherwise you have to use a Boolean expression. So now if you put here, if the inputs are 0 and 0, you can see when you put 0 here, when you put 0 here, it will be 1. So answer will be 1. When you put 0 and 1, when it is 0, it will be 1. So answer will be 1. When you put 1 and 0, again actually answer will be 1. When it is 1, 1, 1, answer will be 0. So therefore, these are the relationship between input outputs A and B, and this output. Then if you take this one, when you put 0 and 0, answer will be 1 because not gate this one. When you put 0 and 1, answer will be 0 and not 0 is 1. When you put 1 and 0, 1 into 0 is 0, not 0 is 1. When you put 1 and 1, not 1 is 0, this one. Therefore, this one is equivalent to this gate. First one. Like you can get this answer using the truth table. That is the easy way to get the answer. Then this one is, I think, bit easier. That is not toe. Not toe means no gate. No gate is actually this one. Okay, then we have to discuss the past papers. So what I will do is actually I will share this tute in the WhatsApp. And again, I will share this. You can get the printed notes once you come to the class next time. However, you can try out those past paper questions. But at the moment, this past paper question, we are just trying to solve using the truth table methodology. But later, we can apply the rules that you have learned. Now we are planning to study the rules in Boolean algebra. Once you learn the rules, that will be much more easier and you can simplify later. So since I have another meeting now, so therefore I'll stop here and then I will start the past paper discussion on the next Tuesday class. Please keep this time, probably 8:30 to 9:30 next Tuesday. Also, we'll have the same class to continue the Boolean algebra lesson. Thank you for joining.